Ladies, this is Honors Pre-AB, Pre-Calculus, Chapter 2, Roman numeral 6, Example 4 from your notes. We started this problem in class today, but did not have time to adequately complete it. So I'm going to help you find the zeros of this polynomial in two different approaches. So the first approach would be that you would look at this and decide, oh, I want to find the zeros by factoring. So let's start out considering the fact that you're going to begin by factoring. So you notice that there are four terms and there's a GCF of x. So when you factor out x, the remaining polynomial is x times x cubed minus 5x squared plus 3x plus 1. And then, of course, you set that all equal to 0. So you now have x equals 0 and your degree 3 polynomial equal to 0. You know that this is degree 4, so you're going to have 4 zeros, and your first is x equals 0. Now this remaining polynomial, you could try to factor it again by grouping, but once you grouped and factored the GCF out, you would quickly see that there are no further common factors. So at this point, you would try P over Q to find your possible rational zeros. So the factors of the constant, plus or minus 1, over the factors of the leading coefficient, plus or minus 1, tell us that we have possible rational zeros at positive 1 and at negative 1. Remember, these may or may not be the actual zeros, and I've given you permission to graph this on your graphing calculator to confirm these zeros. If you want, you can plug one in and get the zeros that way. So let's take a moment and graph the cubic polynomial, or the degree 3 polynomial. So sketch that, graph that on your graphing calculator and pull it up, please. Okay, so I've graphed that polynomial here, and I see that it crosses the x-axis 3 times. So I have 3 real roots shown on this screen. Remember that because we are graphing the degree 3 polynomial, this x equals 0 will not show up. It only comes from the x to the 4th polynomial. So I have a root at, remember my possible rational roots were 1 and negative 1. So I will check now, menu, trace, graph trace, and if I'll just type in x or 1 for x equals 1, and it does show me that I have a 0 at 1. Now I don't see this crossing at negative 1, but if you want to check it, you can, and you can see that your y coordinate is negative 1. So at this time, one of my 3 real roots is x equals 1, but the problem is I don't know what these other 2 roots are. Well, they're obviously not imaginary, so that means they're going to have to be real and irrational, and they are irrational because they did not show up in my possible rational roots test. So if we know that we have an x-coordinate of 0 and an x-coordinate of positive 1, and I should say x-intercepts or zeros of 0 and positive 1, how can we use those to find the remaining 2 roots? Well, if you said synthetically divide, you would be correct. So let's begin by synthetically dividing by 0. We could begin with synthetic division of 1, but I prefer to start with 0. So we will put 0 in our box and list our coefficients. Now remember, these are both roots of our degree 4 polynomial. So I will use these to reduce the degree 4 polynomial. You know, I just realized something. I don't need to synthetically divide the degree 4 polynomial. If I synthetically divide it by 0, it will reduce it to this polynomial that I have already found, x cubed minus 5x squared plus 3x plus 1. So synthetic division of the original by 0 will give me the degree 3 polynomial that I already have. So let's take that degree 3 polynomial and synthetically divide it by 1. Aren't you glad I caught that now so you didn't have to listen to all of that? The coefficients of the degree 3 polynomial are 1, -5, 3, and 1. We'll begin by bringing down the 1, and the product, 1 times 1 is 1. The sum, -5 plus 1 is -4. The product of -4 times 1 is -4. The sum of 3 plus -4 is -1. And the product of -1 times 1 is -1, and I have a sum of 0. So now I have the polynomial x squared minus 4x minus 1. Set that equal to 0 to find the remaining zeros. Well, this obviously will not factor. We already recognize that it shouldn't because we know the other zeros that we saw in the graph were complex. So let's solve this using the quadratic formula. X equals the opposite of b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. So that gives us 4 plus or minus the square root of -4 times -1 is positive. So 16 plus 4 is 20, all divided by 2. So we have 4 plus or minus. We know that 20 is 4 times 5, which gives us 2 on the square root of 5, all divided by 2. I recognize that 2 in the denominator and 4 and 2 in the numerator are all divisible by 2. So we can reduce this to 2 plus or minus the square root of 5. So now we have all 4 zeros. The complex numbers 2 plus or minus root 5, 0 from our original factorization, and 1 from our reduced degree 3 polynomial. Now, if you would like to watch me work this problem by not factoring the original at all, keep watching. If you're satisfied with this explanation, you can turn the screencast off now. So let's say that we decided not to factor the GCF out. Then we would graph this polynomial itself. And I've got that graphed for you. And if I check the graph here, I see that I do cross the x-axis in 1, 2, maybe 4 places. Let's zoom in to see if we're turning there or if we're crossing. I'm going to zoom in a couple of times, and yes, we are definitely crossing the x-axis a third and a fourth time. So we see that we're crossing at x equals 0. So we have 0, 0, and then let's check 1 also, and x equals 1. So we know by sketching the graph of this that we have zeros of x equals 0 and x equals 1. So to reduce this, we can begin our synthetic division. I'm going to choose to divide by 0. You're welcome to start synthetically dividing by 1. So our coefficients are 1, -5, 3, and 1. And we begin by bringing down the 1. 1 times 0 is 0. Negative 5 plus 0 is negative 5. Negative 5 times 0 is 0. Oh, I made a mistake. Oh, no, I haven't. Okay, we'll fix it together in a moment. 3 plus 0 is 3. 3 times 0 is 0. 1 plus 0 is 1. And then you may have already caught what I failed to do. There is no plus x to the 0. Nope, that's wrong. There is no constant term. So our constant term is 0x to the 0. So I need a place marker for that final constant term 0. We have x to the 4th, 3rd, 2nd, 1st, and we have to have a place marker for x to the 0. 1 times 0 is 0, and we do get a remainder of 0. Now remember, this only simplifies to a degree 3 polynomial, but if you compare this to the previous example, previous page of the example, it's the identical polynomial. So you would follow the same process as synthetic division by 1, and then you'll have all 4 zeros. So let me remind you, using the rational zero test will not give you all the zeros of the polynomial. It will only give you the possible rational zeros of the polynomial. So positive and negative 1 are both possible rationals. We found that positive 1 was the rational. We used that to find the other values which were irrational. Thanks, ladies. Let me know if you have any questions.